Okay, for this lesson today, what we're going to start going over is some fittings and some pipe supports that we commonly see and use in hydronic and steam heating. So, in hot water heating, you will most likely see a combination of some cast iron and some copper. If you're dealing strictly with a steam heating boiler or steam heating unit, you're most likely going to wind up seeing nothing more than just cast iron throughout the entire piping circuit of that boiler. But so for the purpose of this, we're going to kind of talk about like a combination of different things. So copper tubing really didn't come into play when it came to piping heating circuits until really the 1920s, simply due to the fact is that it provided a different alternative means of running our pipes instead of having to use heavy cast iron piping. So it's really a combination of application and what we're doing to decide what type of material that we're going to most likely be using. So desirable features when it comes to, copper, really, it's got good pressure. It can handle a good amount of pressure. It can have some good temperature ratings for a typical hydronic application. It has good resistance to corrosion, especially when we are on those water-based boilers and fluid systems. It does have a smooth inner wall, which will offer a very low flow resistance to that particular application. It's much lighter than steel and iron, and we can actually use smaller sizes that can actually produce the same amount of flow and the same amount of BTUs of that of an equivalent size of cast iron. So with these types of things, we no longer will have to cut and thread the cast iron. Now we have the ability to join the pipes together using soft soldering, fluxing, brazing type connections. Today, we have different means of doing things versus having to, spend a lot of time measuring and cutting and threading, like I've said. So, copper pipe is available in a wide range of sizes and different wall thicknesses. Usually when we talk about hydronic heating, remember, we think about all of our distribution piping like our conveyor belt. It's our water tube. It's the way we're going to get the water from the boiler to our baseboard or steam to our radiators. In the United States, basically, copper tubes is manufactured according to a lot of strict standards that they have to follow. For one of those standards, it's the ASTM B88. Which stands for the American Society for Testing and Materials. They go through strict testing and make sure that the copper pipe is within specific standards and able to handle certain water and certain characteristics. So according to the ASTM B88, the copper water pipe size refers to its nominal or nominal inside diameter of the pipe. Okay, the word nominal means that it's measuring the inside diameter. That is the approximately equal to the stated pipe size. Anytime you hear what is its nominal size, we are talking about the inside diameter of that pipe. Your outside diameter of copper water tubing is always an 1/8 inch larger than its nominal inside diameter. Okay, so for an example here, we're saying the outside diameter of 3/4 inch pipe type M copper tubing is 0.875 inches. This is exactly 7/8 inches, or 1/8 inch larger than its nominal pipe size. Copper water tube is available in 3 wall thicknesses designated by a letter. It's going to be either type K, type L, and type M. Okay, in order of decreasing wall thickness. Okay, the outside diameter, however, of all 3 of those are always identical. This allows all 3 types of tubing to be compatible with the same fittings and valves, depending on what we're doing here. The 3 types of copper tubings are usually identified by the color code that's going to be printed right on the outside or the outer wall of the pipe. Type M is usually going to be stamped in red. Type L is going to be stamped in blue. Type K is going to be stamped in green. Because of your operating pressures of residential and light commercial hydronic heating systems, usually they are very relatively low in pressure. So we are going to use the thinnest wall type copper tubing that is usually used, and that's going to be type M. Type M tubing is usually piped on all of our residential and light commercial hydronic heating systems. This wall thickness provides several times the pressure rating of other hydronic heating components. 2 common hardness grades of copper water tubings are available. We usually have what is called hard-drawn tubing, and those are going to usually be bought in straight, rigid lengths of anywhere between 10 and 20 feet long. It's because of the strength, the straightness and strength of hard-drawn tubing. It is most commonly used type of copper tubing in all of our hydronic systems. Reason why we use a lot of hard-drawn typing, not only because of its strengthness and strength, it's because a lot of your piping is going to be exposed. People are going to see it. So what makes a job look really nice and neat? It's nice straight lines, nice straight water lines running along a basement or in an attic or what have you. So if we don't use hard-drawn tubing or soft-drawn tubing, it's going to kind of look like crap. So we use hard-drawn simply for, artistic and characteristics of actually making our jobs look neat. That's what hard-drawn tubing would actually look like. They come in all different sizes, but usually they're nice and straight, they're rigid, and in order to use this, we are going to measure and cut them to length for what we are using them for. Soft-drawn tubing is actually annealed. So during the manufacture, it is allowed and it's heated up and it's formed by using bending tools so that we can actually take this copper and bend it into 90-degree, 45-degree angles, what have you. Okay, it is very useful in situations where awkward angles do not allow proper tubing alignment for, obviously, standard fittings. So in the process of copper, what we usually do when it comes to annealing copper is we usually heat this material until it actually glows bright red. And for a while we do this, it's allowed to cool. And when we do this, we are actually able to bend and shape the copper to whatever bend that we're trying to actually accomplish. Okay, usually when we get it, it's going to be rolled up in a coil like you see here. And as we use it, we can simply unroll it, use benders and such to create angles and bends and stuff like that to get around obstacles in a basement or going through a wall or whatever. This is the type of copper that you're going to use. Hard-drawn copper tubing supports, when we are hanging or using any sort of copper, we have to support it in some sort of way. If we are dealing with hard-drawn tubing, we are going to make sure that our supports are every 12 feet of horizontal run going along a the rafters in a basement or hanging it above in a ceiling somewhere. Those hangers are going to be every 12 feet. If we're going to be taking this hard-drawn copper tubing and we're going to be running it along vertically or going up a wall, we're going to try to make sure that they are every 10 feet. Okay, obviously, these are guidelines based off of the International Mechanical Code, but what you should really do is check with your local code authority to see what they require for your proper spacing of your copper tubing. Because remember, in the International Mechanical Code is the bare minimum that people, mechanics, need to follow. Your local governments and municipalities can have stricter codes. So International Mechanical Code may say that they want your supports every 12 feet of horizontal run, but your local town may say, nope, I want your supports for your copper tubing every 6 feet or every 7 feet. Whatever your local code official says, that's what you are going to put for your supports. These support spacings do not include any allowance for any extra weight of the other system components, such as circulators or expansion tanks. So if you do have those types of components in your system, you need to make sure that you properly support them by adding additional hangers or additional supports. When such components are present, the piping should be supported immediately adjacent to those components, either before or after, or on either side, to make sure that those components do not sag or put extra weight on the pipes. Copper soft-drawn tubing of 1.25 inches or smaller on a horizontal run must be supported at least every 6 feet. Copper soft-drawn 1.5 inches or larger on horizontal runs should be supported every 10 feet. Okay, vertical spacings on all sizes is every 10 feet. A number of different types and styles of supports are available for us to use depending on what we're trying to do or what we're going through. And we have a couple of them here. You have your split ring type supports. These can usually be connected with threaded rod so that you can hang them from a ceiling or support them in some way. You have an adjustable strap, which kind of uses the same thing as your split ring. This one here, you just kind of measure how up or down you want your pipe to be, and you throw a screw or a nail through there, and you're able to support the pipe. You have your 2-hole pipe straps, which are basically, as you can kind of see them, the pipe runs through the center there, and you just nail it to a rafter or screw it into something. Your bell hangers is the same type of thing. You just screw it into a rafter, and you put your pipe right through the center there. You have your J-hooks, and then you have your clevis hangers, which is going to be used a lot for your cast iron. You also have some plastic 2-hole straps that you can get. You have pipe insulators if you're going to be running copper pipes through studs in a wall. You have copper straps, which you obviously will just roll out and cut according to length and use accordingly. Very common that you see is your strut cushion clamps. In order to use those, you have to use unistrut. And the unistrut is what you use to actually clamp and hold the pipe in place. And if you're going through a floor, you're probably going to run into a vertical pipe support. The pipe runs right through the center, and those pipe supports just kind of sit on the floor and just hold the pipe in place. A lot of our common fittings that you're going to see when doing a lot of piping and hydronic work are your couplings, reducing couplings. Reducing couplings obviously take copper pipe from one size to another. You have your 90-degree elbows, 45-degree elbows. You have your street 90s and 45s. You have your standard tees and your reducing tees. You have male adapters and female adapters, depending on you're using these to thread into boilers or into circulators and stuff like that. You have unions. You have sweat ball valves where you're actually going to be soldering into place, or you'll have MPT ball valves, which are simply threaded into your cast iron. You'll have gate valves, which are going to be used to shut off water flow throughout your, radiators, baseboard, stuff like that. You'll have boiler drains used to purge and remove air from your hydronic systems. You'll use them to drain boilers and to add water to a system in some cases. You'll have boiler drain tees, and you'll see baseboard tees.